I am the professional developer at the Lemelson-MIT Program. Thanks a lot for your interest in the webinar this evening. Welcome you all. As a lot of you are aware of, starting last October, we have been offering a series of free webinars once every 2 weeks. The topics are organized around minds-on and hands-on skills. Those, as we see, those are essential skills to invention. This week, we will talk about one of the hands-on skills that's about troubleshooting electronics. Next time, we will talk about a hands-on skill that's about showcasing the inventions in your community. Okay, so all of our previous webinars have been recorded. You can find the recorded webinars and the slides on our website. Specifically, if you go to the lemelson.mit.edu, you go to the Resources tab, and you will find them right under the Invention Resources. After this webinar, we will send out a separate email about how to access this recording and also how to download the slides. The email also has information about how to register to the next webinar, so please keep an eye on that. For today's webinar, as you will see that we will have set up a chat window for you to post your questions. At the end of the presentation, we will have about 5 minutes to answer the questions. You don't need to turn on the microphone on your computer. Okay, let's get started. First, a brief introduction of our program. The Lemelson-MIT Program is a multifaceted program for inventors at all ages. The Invention Education Program includes specifically 2 grants initiatives. That's the 2 orange bubbles on the right side. The first one, the Inventive Grants Initiative, is a grant specific to support high school teachers and students working on their self-identified invention projects, where each year we support 15 teams across the United States and provide them free staff support and also up to $10K to support their invention projects. And throughout the years, we have worked with over 200 high school teams, and 7 of them have been awarded with US patent. A lot of them are now in the process of applying for US patent. As you know, patents kind of typically take a few years for you to get it. And lots of our students have presented their work at the White House Science Fair and also other local or national or state level conferences like science fairs or maker conventions. So the second grants initiative of our Invention Education Program is the JV Inventives Grants Initiative. That initiative provides free curriculum to all teachers and students, and we specifically designed 8 JV Inventives guides that's mainly for middle school students or early high school students. And also we provide free staff support and materials to 4 areas in the United States. If you are interested in either of these grants initiative, please feel free to contact us about that. This evening, I'm very happy to invite Doug Scott to share his experience of helping students troubleshoot during invention projects. Doug is a high school robotics and engineering teacher at Hopkinton High School. He is an inventor. He is the STEM Teacher of the Year in Massachusetts in 2014. In 2013, at that time, Doug was a teacher at Natick High School. He led the Natick High School invent team, and they together invented a great device to help find potential survivors in the water, especially for the winter time. In 2016, their invention was awarded a patent. So Doug, welcome. Can you tell us more about the inventions you guys work on?
Yes, when you speak of troubleshooting, to put it in context for tonight's webinar, I considered the whole experience to be troubleshooting. Initially with trying to identify a unique problem that the students would try to solve and come up with a unique solution to that. And in doing so, what they discovered was the hardest part of the process was identifying a problem. one that they could latch on to, one that was linked to the community, um, and one that could provide them an opportunity to learn a myriad of skill sets. And through their determination and hard work, they did end up finding a problem that for them made a lot of connections in their community and really connected them to each other over time because they did learn how to problem solve and how to troubleshoot. So this experience was one that truly changed a lot of students' lives. They still keep in contact and refer to this project as one that really changed their lives. It certainly was an experience for me that changed the way that I teach. Um, I always hear people refer to things as project-based learning, but I typically refer to it as problem-based learning. Um, my thought with that is that it's uh, more accurate to say that you're developing problem-solving skills and trying to identify problems more so than just working on a project. So it was a great experience and one that certainly had a wide impact on a lot of people.
Yeah, that's a wonderful experience for teachers and also for you and also your students. I wish the students a lot of troubleshooting skill they learned, probably they are still using it right now when they are working on their new projects.
Sure.
Yeah.
Yeah, and I always joke with students, even now in my engineering classes, I'll say how many people want to become an engineer, and a few kids will put their hands up, and then I'll say how many people want to own a house, and most people will put their hands up, and I say, "Oh, well, if you're going to own a house, you'll be an engineer before you know it."
Yeah.
So,
Especially in snowing days.
exactly.
Yeah. Yeah, great. Yeah, Doug. Yeah, it seems that the invention, yes, it is actually student needs to do a lot of troubleshooting during invention projects, and that's going to be some those kind of important skills that's going to benefit them probably throughout their life. Yeah. Okay, so now before we start talking more about troubleshooting and having Doug start sharing his experience, first I want to talk about briefly our definition of invention. Our program specifically focuses on technical inventions. We feel that there are three distinct characteristics of invention. First, it needs to be useful. That means it needs to be useful or beneficial to certain people, to certain clients or users. Second, it needs to be unique. That means it needs to be something was not previously known. And third, invention needs to be reduced to practice. That means it needs to be more than ideas. Sometimes students will have great ideas, but they have no way to even think about how they can potentially make those ideas into realistic prototypes. So it's important students will be able to make their ideas or prove their concepts through by making some kind of prototypes. Throughout our 15 years of working with students, we observe that students typically go through 4 phases during invention. That is about finding problems, doing some research, and then designing, building, and testing their final projects. So what happened is when you were thinking about troubleshooting, you might think, okay, troubleshooting probably what happened when students started building and testing their stuff. That's where they find the problems. But in fact, many times you will find the students actually start doing troubleshooting when they are in their initial design phase or when they are trying to start working on their early prototypes. Many times what happened is that when they were working on their design phases, a lot of times they were doing troubleshooting that the troubleshooting results will directly impact the building or the testing plans. And at the same time, often when they were doing the troubleshooting during building and testing phase, the results will also make them realize their initial design doesn't work, so they have to revise their innovations. So overall, we feel the troubleshooting is a vital skill throughout literally all phases during invention. So nowadays, especially with the popularity of the internet of things like sensors, like a lot of students use boards like EXP boards, Raspberry Pi, or Arduino, all these kind of things, we see that more and more students' invention project now include two parts, the mechanical part and also the electric parts. Just like the invention Ducks group created, you guys have the robots, the remote control of the submersive and non-submersive vehicles. Those are the parts that use a lot of the chips and all the programming and creating robots. That's the electronic part. But at the same time, you are trying to use a connector to connect the submersive and non-submersive part. That part is the mechanical part. Students need to do lot more troubleshooting. That means they need to troubleshoot the electronics, they need to troubleshoot the mechanics, and also they need to troubleshoot when they are trying to put these two parts together. For our today's webinar, we specifically will only focus on troubleshooting on electronics, but we feel lots of the skills students learn throughout the troubleshooting will also be applied to other troubleshootings in their invention projects. Okay, so troubleshooting also we feel in general, it's different for every situation. Even when students are working on the same invention project, they will experience different problems, need to do troubleshooting to find all the solutions for different situations. And the troubleshooting skills in general come only with experience. So it is important that educators would help foster troubleshooting skills early in invention. But at the same time, you might think, okay, so if troubleshooting is so different, what can we do about it? But at the same time, we find there are some common problem that as a teacher or as a student, if you know those common problems, that you can use those and you can potentially diagnose those problems relatively quickly and relatively easier. So trying to understand these common problems and also learn about how to check them is kind of a starting point for both students and teachers. Today we will ask Doug to share his experience and some of the common problems he sees in his students. Next, before I ask Doug to start sharing his experience, I just want to emphasize all the safety rules because when students are working with electronics, they're working with batteries, circuits, and all the kind of tools. So it's very important make sure that the students will understand all the safety rules. I wouldn't go through the long list here, but I want to just emphasize, please make sure that students knows how to use a tool before they start using it, and also make sure that students have a plan so that they have some plans before they start working on that. Okay. So next, Doug, can you start by talking to us about some tools that can be commonly used when trying to troubleshoot circuits or batteries or electronics?
Sure. Certainly one of the go-tos is your multimeter, and I have mine here. A multimeter, it can range in expense. This one that I have in my office that I use is a little bit more expensive, but you can get a functional multimeter for your classroom around $10. You can get a decent one. You do have to be careful with the students in terms of cords. If they pull on them, they can break the connections at either end. So it is a good idea to walk them through the process of taking care of the multimeter and making sure that they turn them off when they're not used. But the multimeter is a fantastic tool for checking the voltage output on battery systems, on circuits. Um, it's a great way to use a continuity tester on the multimeter. It's a setting on the multimeter which allows you to see if there's a short in a system, so if something's shorted out, or to see if something is in fact connected. A lot of the times people think that there may be a programming issue, and it's interesting if you've ever worked with students on programming and hardware at the same time. The programmers will blame the hardware people, and the hardware people blame the software or programming people. And somewhere in between lies the truth, and oftentimes it is a connection. And testing cables to see if there is continuity, or checking to see if there is power being output from a system, a multimeter is a great tool for that. Uh, if you buy a multimeter, read the manual. There's a lot of great information in there because usually there's about 24 settings on a multimeter. And if you don't know all those settings, you may be missing out on some opportunities to use the meter for certain skills or tests. And the other part is you certainly don't want to damage the multimeter or blow out the fuse inside of it. They typically run on 9-volt batteries. There is a fuse inside that if you go over the rating in terms of the current, you can blow out the meter. So you need to certainly read the instruction set with it, but a great tool. The item on the right on the slide is a battery tester. This is a much simpler way to test battery power, how much power is remaining inside of a battery. It'll give you a voltage reading. In this meter, if you can kind of glance at the meter portion of it, you'll see there's a red section, a yellow section, and a green section. The red will just say replace, and if you're inside of replace, you replace the battery. Yellow is moderate, and then green is good. On a multimeter, you can perform the same task and get voltage readings, but the battery tester is a nice simple way to test really quickly. So both of these tools are pretty useful in a shop or in a school setting where you're doing any sort of circuitry. Some safety tips down below in yellow. Certainly don't tip car batteries. If you tip car batteries, some of them are not sealed lead acid batteries, and you potentially could spill some fluids that are harmful. Do not cut open batteries that may contain acid liquids inside. Allow young children to work with, do not allow children to work with coin cell batteries. It says on here allow them to, but I think that's a typo. Don't allow young children to work with coin cell batteries. They oftentimes will try to swallow them, thinking that they're like a treat, or they'll play with them and accidentally swallow them, and it can cause quite a bit of havoc on a person's digestive system, especially if it's lithium ion. If you have any lithium ion batteries that you're working with, please never submerge them or get them wet. They react pretty volatilely with water. And the last item on there that says store 9-volt batteries loosely. Do not store 9-volt batteries loosely. They could cause a fire. I've had students do this. I had a student one time put a 9-volt battery inside of a metal toolbox, and that 9-volt battery actually welded itself to the side of the metal toolbox and had swollen and was very hot. Luckily, I found it before it potentially could have caught on fire. But if you've ever seen any camping videos or anything like that, you'll oftentimes see a survival technique is if you take steel wool and apply it to a 9-volt battery, it will actually catch on fire. So be very careful of 9 volts just because the terminals, they're so close in proximity, you potentially could short them out and cause a fire. So 9 volts I'm particularly careful with. You have to store them, make sure you wrap them with a piece of electric tape over the terminals. That's just some safety and tools. Troubleshooting circuits. I always, when I used to teach computer classes, I used to always say start at the wall, start at your power source. And even then, what will happen is you will get into bad habits. You'll start to rely on previous experiences, which can actually get in the way of troubleshooting. It's good to have a methodical approach to troubleshooting. I can remember a time where I was working with a student. We determined that the computer system was totally dead, and what had actually happened was I had ignored the advice that I had always given, which was to start at the wall and check the original power source. So checking the power source is always a good first step. It's what I would consider a shallow dive. It's a way to do something very quickly to determine if you actually do have a good known power source. So is the battery good? It's a good thing to check.
Yeah.
And Typically, you'll find if you're checking batteries, like a 12-volt battery, if it's hot off a charger, it will oftentimes read around 14 volts. Uh, a good 12-volt battery will typically read anywhere from, 13 to 13 and a half if it's cooled down a bit off a charger. Uh, if you start getting down well below 12 volts, it could be an indicator that the battery is drained or too weak if it's a 12-volt battery. Um, so going through all the devices in a circuit, if you're trying to light up a light bulb, is the light bulb actually good? Um, Checking for wires to see if they're good, to see if it's a good conductor. Again, you can use a multimeter to see if you have a complete circuit using um, a continuity tester on a multimeter. What that can do is provide you with the opportunity to see if you actually do have a good connection. So when you're working with your power source, make sure that the battery is not installed backwards. These things happen quite a bit. Test out the battery. Again, like we just mentioned, make sure that it is good and ready to go and has a proper reading. Also, make sure the battery is fully connected. You may have corrosion on contacts. This typically happens when you leave batteries inside of devices for quite a while. You can clean those off with a wire brush. Also, be careful too. I've seen the spring contacts inside of systems. They will sometimes bend and not be in full contact with the end of the battery. So if you're using like a AA or a D size battery, make sure that the spring is actually in contact and clean the connections at both ends. So making sure that you have good connection is also important. When you're working with LED bulbs and LED light bulbs and standard incandescent light bulbs, the orientation of an LED is interesting. The longer side is the positive side of an LED, and it does matter. Typically, when people are working on a DC circuit, you'll do things, and it really doesn't have a major impact on the flow of electrons. But being a diode is basically like a one-way valve for electrons. It will only allow it to flow in one direction. So if you push the electrons in a circuit in the wrong direction, it will not light up. So you need to make sure that you have your positive lead from your battery or your circuit engaged with the long terminal on the LED bulb, and the short side is the negative. If you're working with coin cell batteries, it's a great way to actually just touch the LED to the coin cell. You can just kind of pinch it between your fingers and you'll light up the LED. Again, making sure that the orientation is long side on positive. When you're working with different color LEDs, just be aware that different color LEDs require different voltage ratings. So sometimes you may be able to light up a red LED with a typically lower voltage output battery. But if you are using something like a blue LED that requires more power, that same battery may not light up that blue LED. Always check that the LEDs are connected firmly. A great way to do all of this, this and the prior slide, a great set of tools to use is alligator leads. You can get like 18-inch, 20 gauge, or 22 gauge, depending on what you're working on, alligator leads, and by using those, you can really clamp onto the piece. So when you're working with copper tape, conductive thread, and wires, you always want to make sure that you have continuity. So when you put down the tape, the copper tape, always make sure that you're working with the correct side of it. And it sounds silly, but you could potentially end up trying to conduct on the sticky side. Also make sure that you are careful that there hasn't been any oxidation on it. You sometimes have to scratch the surface a little bit just to clean it off to make sure that it's that it has conductivity. Also making sure that there's no breaks in tape. This is a circuit, and if you have an incomplete circuit with a piece of broken copper tape, it's not going to work. Make sure that with the tape and the thread that they don't get tangled or looped. You don't want to do that. When you're checking connections between the tape and devices, make sure that you put down sufficient pressure on the tape that holds the LED legs in place. Or if you're using it for other devices, make sure that you have a good firm contact with that tape. If you just lightly touch it, it doesn't always work. When you're going along, if you have to create any insulation, electrical tape can certainly be used. If you're looking for shorts in a circuit, use the multimeter to check for it. And in this photograph, you'll see I'm using a multimeter on a paper clip, which is certainly one complete circuit in itself. And by using the continuity tester, the multimeter will emit a tone as well as get some fluctuation in the power reading. Okay, so when you're working with electronics and you're soldering, soldering is kind of the next level when you allow students to get into soldering. Certainly go through some safety tips with soldering. Soldering irons can get upwards of 400 degrees, 500 degrees, and that's can really do some damage to a human skin, so you need to be very careful of it. Safety glasses are always on when doing this, and certainly washing hands afterwards is a must. When you're working with boards, if you have a ground signal on a board, you can again use a multimeter to check to see if you have continuity from one grounded component or one grounded terminal to another that you're working with. Making sure that if you are soldering things down, that you are soldering them in the correct orientation and making sure that you are not applying power to the inappropriate terminals on a device. When you're soldering correctly, you want to make sure that everything is in its correct place and you're soldering, and that you're not creating bridges by putting down a clump of solder that actually comes in contact with several pins or contacts. And you want to make sure that that the solder is shiny. You don't want to look for, if you have gray clumps of solder, it typically means that it didn't bond properly or cure properly. You want to have a nice shiny solder point. And again, making sure that that solder is not bridged or touching other components on the board, because you could potentially short them out. So the big thing is, you'll see the photograph on the left of some of my students working on a project. This was not a stage photo. The kid on the left, Jimmy, he actually looks like he's doing his best imitation of the thinker, but he actually was thinking about something. Ford was on the ground, and Nick and Jason were in the back. I kind of caught them midway through this photograph. And one of the things that you always need to encourage your students to do is to troubleshoot, but always keep in mind that there are times where you need them to step back, think about it, look at it, sometimes take a walk, get a fresh perspective on things. Sometimes you just can't see what's going on. And again, that's where a methodical approach to troubleshooting can really be helpful. If you look up troubleshooting flowcharts online, you'll start to see it's basically a Boolean type or yes/no series of questions that you can ask yourself as you're trying to work your way through a problem. These students did a lot of troubleshooting in the shop. And then on the right, you'll see some students that were Olivia and Caitlin, who were with President Obama at the White House Science Fair. They had a sheet that they had worked on before going into the White House on what to do if they experienced problems with the machine. And about 30 seconds before the president came through the door, they lost all Wi-Fi connectivity between the control system and the two-part robot. And rather than panicking, because they had prepared and because they had a methodical approach to troubleshooting, they recycled the machine twice and were able to reconnect to it just as he was walking through the door, and he was able to drive it successfully, which really made for their showcase of their invention. So if they had not trained themselves to troubleshoot in that manner, they probably would not have been as successful as they were.
Wow, this is a wonderful story about this. Yeah. I'm really happy for the girls. They remember and learn about all the troubleshooting skills so that they make it really useful right before their presentation. Yeah. Okay, thank you very much, Doug, for sharing the experience and all the tips. I hope those experience and tips are useful to you as a teachers or as an educator who work with your students. Here, I just want to share some resources that could be potentially useful to your program. First is all our resources on our website, including our 2 grants initiatives and also about the description about our program. And next, these are just some resources that we think are particularly useful related to troubleshooting electronics, like the smartphone, and also Don Domes have a great video. Don Domes is a math teacher working with our groups. So these 2 websites has great resources on how to use multimeter tool. As Doug mentioned, multimeter tool could potentially be very useful in troubleshooting. And also all of our circuits offer the circuit troubleshooting worksheets where they present different scenarios about problems so that can guide you to work step by step to troubleshoot. And next, I want to make 2 announcements. The first one is about our Inventive Grants Initiative. So the application for next school year is early next year. So if you are a high school teacher or you know any high school teachers or students who are interested, please feel free to contact Tony. Here we have his email address and his phone number to ask about that application. So we invite everybody, please try to apply to this. Yeah. And next one is about the Lemelson-X website. We recently launched a online invention educator community that is the lemelsonx.mit.edu website. We encourage everybody to try to sign up to the website as we are populating this website. We are inviting all the teachers we have worked with, the teachers you think you have done something related to design, related to invention, please feel free to share your experience and have everybody know your students' work. And so hopefully this online website will become our virtual home. Yeah. Please feel free to check that website and you will see a lot of people started sharing. A lot of our math teachers have started sharing their projects there. Okay. So next I think that you probably have about 5 minutes. We can answer some questions.